Okay, so here we have one more example with finding with working with hyperbola. This one, like the ones we did for an ellipse and for a parabola, is in a different format. So we focus only on that now. Uh, 2y squared minus x squared plus 2x plus 8y plus 3 equals 0. So we first have to put it into the right format. So we do a couple of things here. I group my y's together. And while I'm at it, I go ahead and factor out the 2, because when we complete the square, we don't want anything in front of the squared term. And I group my x's together, and while I'm at it, I go ahead and factor out the negative sign, because again, we don't want anything in front of the squared term. And then I took the negative 3, and I slipped it over to the other side. And at this point, we want to complete the square. So we look at y squared plus 4y. So, okay, well, we have to take half of that number, 4y. Half of the 4 is 2. 2 squared is 4. So we would say plus 4. It's an equation though, so we have to do the same thing to both sides. So on the other side there, I say, well, what I really added was not 4, but 8. So I add 8 to the other side. And then we go to the x squared minus 2x. Take half of minus 2, we get negative 1. Negative 1 squared is 1. So we have to add a 1 to complete the square there. But because of the minus 1 outside, what we really added to the equation was not a positive 1, but rather a minus 1. Okay, we can then simplify. The two quantities in parentheses, because we've now completed the square, can be factored. So we do that. Okay, and simplifying on the right-hand side, we get equal to 4. Okay, at this point, to put it in the form for hyperbola, and we know it's going to be hyperbola because one of them is minus. If this was an ellipse, they would have been plus. So we divide by the 4 so that it's equal to 1. And that gives us the equation now in the more standard form, y plus 2 squared over 2, because 2 divided by 4 would be 2, minus x minus 1 quantity squared over 4 equals 1. So we immediately recognize, because the x squared is being subtracted, that this is going to be a vertical opening hyperbola. And then we can start piecing together our parts of our information. Our center will be at 1, negative 2. A, which I'm just taking to be what's under the x. A squared would be 4, so A is 2. It's horizontal. B squared is equal to 2, the thing under the y. So B would be the square root of 2. And we can also solve for the focal length, which we'll need to answer the question, where are the foci at? That would be a squared plus b squared would be equal to 6, and so c would be the square root of 6. Okay, at this point we really have two parts of the problem. One is to graph it, the other is to figure out where our vertices and where our foci go. So to graph it, we begin by drawing our axes, and then I plot my center at 1, negative 2, so there he is, my center. And then because it's vertical, both foci and vertices are going to be above and below the center. Since they're going to be above and below the center, the x coordinate on those will be the same as the center. It'll be 1. Now my first vertices, underneath the y's there we have a 2, so b was equal to square root of 2. So the vertical is up and down, square root of 2 units. Square root of 2 is about 1.4. So when I graph those vertices, I'm going to go about 1.5 units above and below the center. Okay, and then my foci were square root of 6 units from the center. Square root of 6 is a 2 point something. So when I draw that, I'm just going to go a little bit more than 2 below and a little bit more than 2 above. Those will give me my foci. And then remember, we use the other dimension, in this case a equals 2, to go 2 units left and right of the center. And that allows us to construct what's called the auxiliary rectangle, going from 2 units left and right for each vertice, and drawing in that rectangle. Again, the 2 comes from the denominator of the minus term. B is equal, or A is equal to, A squared is equal to 4, so A is equal to 2. We then use that rectangle along with our center to draw in our asymptotes. At this point, we can go ahead now and draw our graph starting at our vertices and going towards our asymptotes. And the last thing we want to do is write down our vertices and foci. And again, we can see from the picture that we're above and below the center. So my vertices, starting with the center, I would go square root of 2 units above and below, so I can write that as 1, negative 2, plus or minus the square root of 2. And then my foci are square root of 6 units above and below. I can write that as 1 comma negative 2 plus or minus square root of 6. Okay, and that is how we work with the equation of a hyperbola and how we use it to find the graph and the vertices and foci.